So in our discussion panel today, we have Eduardo Lazarotto chairing the discussion panel. I'll just give a little bit background. Eduardo Lazarotto is Director, Product Management, Engineering Applications within Bentley Systems. He is responsible for managing the company's modeling and visualization product line, which includes MicroStation, PowerDraft, and Bentley View. So I met Eduardo, I believe, first time in Barcelona in a conference. And we are compatriots. We are from the same country, both Brazilian. And it's a pleasure to have him here and have him steering this discussion. Okay, so Eduardo, I would ask you to, get started and let us know what you think about the session and how you think industry applications will evolve.
Okay, well, thank you very much for the introduction, Abel, and it's great to be here. And same way that it was great actually to see all the presentations between the past 2 days and during the day today. I think the whole flow between algorithms, cognition, cultures, and now concluding with applications was very well thought. I think it gives us a very good way to analyze and to discuss today. So maybe a quick first point in terms of where applications are going and how they will keep evolving. As Abel mentioned, I am the product management lead for MicroStation, which is a CAD application that has been in the market since the 1980s. So it's 30-something years at the moment. I'm sure you guys also have seen some of the other CAD applications that have been in the market for a number of years as well. And since then, we have changed a lot as a company. I think picking up in some of the comments from the sessions earlier today around cognitions, I think there is, around cultures, particularly the question from Flavian around the architect and the software place in our industry. And it's a great point because, first of all, Bentley, which we now refer fondly to as BSY, since we have been listed in the NASDAQ last year, is a company of engineers and architects and people from the industry. So most of our colleagues come from different engineering backgrounds. Unfortunately, I'm not an engineer. My background is in economics, behavior economics, and development economics. But my whole career has been in infrastructure. So I worked in railways and then with London Underground here in the UK before going to simulation of people movement and then joining Bentley via an acquisition. But the whole point of mentioning that is that software development is evolving together with our industry. It's not like we are developing something that we then expect the market to adopt and to make as the new status quo or the new way of deliver projects. It's exactly the other way around. I think we are here to work together with the industry to understand what is the best way to deliver those projects and what is the best way to augment the capabilities and the delivery potential of some of our users that range from architects into engineers in all the different engineering practices, designers, drafters, and all the other users of Bentley software. So looking into the future, of course, there is this very nice idea of digital twins. I think we'll talk a little bit about it in a second. And Greg made a brilliant presentation. The Autodesk presentation was also very good. I think it opens up a world of opportunities as it enables us to simulate different futures, which is a part of technology that has been rapidly advancing over the past couple of decades. Not only because we found new ways of simulating different futures in different sciences, not only in engineering and architecture and design, but also in economics and you name it, in pretty much every single part of our lives, but also because we have been advancing our computational power and capacity. Of course, we have been growing that across different systems by pushing that into the cloud and by enabling multi-threading, multi-processing, by making it more easier to manage with technologies like blockchain, as I was asking a question earlier in the sessions yesterday. And that increased capacity, of course, enables us to test more scenarios, but also to further those scenarios beyond any stretch of human imagination. And I think that is the point where we need to understand that the role of the software developer or the software development company is to work together with the industry to understand our goals. And by goals, we mean improving the lives of the final users of our infrastructure, and how can we get there in the most efficient way. So I think that's my view of the future of applications and what we are trying to do as a company. But it would be great to hear from the other colleagues here in the panel about first their understanding of this correlation between algorithms, cognitions, cultures, and applications from the past 2 days, and then also their views on where are applications going in the future. So I don't know, Greg, do you want to kick off?
Yeah, sure. I can give some comments. I'm sort of curious to see, like, when I think about the future application development, I don't know the answer to this one yet, but this idea of platform versus product, I think, is really interesting. I think that's in some ways maybe what made, I don't know, Rhino and Grasshopper so successful. It wasn't like a set of tools with a prescriptive, set of features. It was meant to kind of enable people to, have a lot of freedom and flexibility. And so I think I'm coming a little bit from that background too, like having gone through the whole like Revit development cycle and like really focus on like a product to try to solve a specific problem. And there's a lot of even critique in the market about, is that too prescriptive in terms of like the history of architecture, and there's a whole debate around that. But then, what does it mean to start enabling the public, like basically anyone in the market to basically build whatever they want with a core set of APIs and services. And so I think you can see that in the likes of something like Microsoft, for example, Azure. If you think about Microsoft going back 15, 20 years, Bill Gates, right? It was just the operating system and Office, right? It was really focused on just delivering products, and we all use the products. Obviously, Excel is still super powerful, but that was like a focus. But then when they made a shift, also Amazon too, Amazon Web Services. You think Amazon is for buying products? It's like a product, you go to the website, but they also have web services. And Microsoft is putting up Azure. And so it's not really, it's just here's web services and you can build what you want with it. In fact, just to be totally transparent, everything that we built with the iTwin platform is resting on the backbone of core Azure infrastructure, cloud storage, cloud processing, web streaming, and also remote rendering streaming. Like what I showed today with the streaming to the HoloLens is something that we didn't write. We're just using a component, and we're sort of assembling all these parts and pieces together and seeing what comes out from that. So I'm kind of curious to hear what people think about that. Like, is it too optimistic to imagine that it's almost like crowdsourced innovation is the way forward versus relying on these single software vendors to keep coming up with like the solution? And I personally believe that the problems we're facing as a society are of such an urgent nature that it makes sense to crowdsource it. So that would be my hope.
That's a great point. Paul, would you like to go next?
Sure, yeah. I don't necessarily know the answer for that question, but I have another, let's say, concern. I usually see like the path of development, at least in software engineering, coming the other way around. For example, solutions such as, for example, React, or everything that's developed by Google, Facebook, comes to architecture afterwards. And I really like the way that you presented the problem. that you consider the architecture industry first, and afterwards you construct solutions for architecture and for construction engineering. I'm personally, I'm curious about that. How much innovation can start from our domain instead of starting from the other way around, from the big companies, and coming to architecture? How much is original and how much is imported and reused? I understand the economic viability of that, but I'm also interested about what can be innovated.
Sure, I think that's a great point, and I think it touches directly on what Greg was mentioning of enabling actually creating a technology that is actually a platform and enabling the users to be creative and to create their own solutions for the different problems that they have. Which I think over the past couple of decades we have been very, very fast learning that the same problems can be different in different contexts, and different solutions might deliver better results for those problems instead of us just trying to force one-way solutions. So it's a brilliant point. So I don't know, Guilherme, do you want to add a little bit from a simulation perspective as well?
Yeah. So on the topic that you mentioned, that we create like flexible platforms. For example, in my in what I presented in my simulation method, I used a Dynamo, and it actually doesn't have. I couldn't find. At least I couldn't find like any library that was fit for purpose for me, like for my ANN mod to create an artificial neural networks model to do whatever. But it gave me the flexibility to actually run Python scripts of my own within. So I was able to code within Dynamo and do whatever I wanted to do, like to develop my simulation method. And I think that this is it is very beneficial for everyone to have platforms that are not products, but you can actually be flexible within them and produce what you want to produce by your own.
Great, thank you, Guilherme. Brandon, would you like to add anything from your side?
I think I tend to agree with Guillermo and I think Paul as well, that in most senses, pieces of software should be enablers. The true IP is in the education that the user has invested in themselves and the way they express their own IP. So I do tend to agree that platforms or opportunities where you can explore or get to a route that you need to get to, and you have that opportunity, that door to open to get to where you want to get to, is critical. And I think it's something we vendors need to consider very, very seriously about that. And obviously we do have our own priorities in terms of our role as a vendor, because somebody has to stand up these platforms, somebody has to invest them and create them and, you know, maintain them, etc. So it's a difficult one. I'm glad I don't have your role in that. What I would say is the next big hurdle is we never really know what data is going to be used to explore an idea. I've been fascinated with the different methodologies and the different approaches people have taken to look at an idea. And it's almost like there is no how can I apologize. I sometimes lack the vocabulary for my ideas that I need to say, but essentially the diversity in the data sources you know, the diversity of the questions that are being asked and the way people create to answer those questions, be it a survey, be it a psychological assessment, be it some other kind of machine learning algorithm. That is the next big challenge. All of these different generated data sources and how you would actually incorporate those in a platform. And that's where I think the headache is for the potentially for the vendors, is to actually provide a platform where all of those diverse data engines, data sources, algorithms, on whatever format that data is, be it, you know, the LiDAR, the context capture, the human skeleton kind of overlays, that kind of thing. How we bring those together is where we need to do a lot more investment, I think.
That's a great comment, Brandon. So maybe let me just conclude on that topic, and then let's move on to a new one. Since we have Shajay here, it will be great to get his opinion as well, and go into another part of the presentations from today. But you just touched on a point that it's quite difficult to be a product manager today. I'm a product manager, and it's a relatively new profession. Again, if we look back at any other industry, product management would be a marketing role on understanding the market, defining a product, and so on. Whereas in software, as we are much faster, much shorter life cycles of development, we created this role. And the sole purpose of a product manager is to create the right product, as we call. And that right product is a product that is desirable by the market and the users, so delivers the value that the users need. It is feasible technically, so we can make it, right? It's like there are many things that we would love to do, but we just don't know how to do yet. And third, it's economically viable. So we have pretty much a margin at the end of the day that pays back on the investment that we put in building that product. And finding that balance between these three components is quite complex, and it's super exciting. It's definitely a nice part of the job, and we count on users, of course, to identifying particularly the desirable and the technically viable parts of that discussion. But as I said before, let's try to move on into another question. I think one of the most amazing parts of digital twins, at least for me personally, I love that part of digital twins. And great presentation by Greg, great presentation by Autodesk earlier today. But the great advantage of digital twins is you collate all that data from across your project during the design phase, or even earlier than that, when you're capturing the context where your project will be built. Then you collate all the data during your design phase, take that through construction, and then you go into operation. But all that data that you have collected enables you to simulate future scenarios of operation, which I think Shajay did an amazing presentation on changing infrastructure or buildings after we build them, according with the needs of those buildings. So I think that is definitely one of the ways to inform that process of change. And then my question is around, how do we understand that process of simulation? And again, simulation goes way beyond the concept that we had 20 years ago. Today, we can simulate both infrastructure aspects like structural engineering, and of course, all the sensors, as we mentioned before, future variations of those sensors and usability of that space and so on. We can simulate people movement, either walking or cycling or in cars, or even as we saw in the presentations earlier yesterday around neuroscience, on modulating choice and trying to understand choice and so on, or all the way to environment, as we have been doing for years in Bentley. We now simulate weather, currents and water and sea, and the impact of global warming, in potential disasters in cities by the seashore, as well as subsurface structural engineering and all the impact that the subsurface realm has in the projects that we deliver. But my question is, how do we assimilate that simulation data, and how do we see that accelerating the delivery of better infrastructure for the final user? And I don't know, Shajay, if you want to start from your side and tell us a little bit more about your experience at Zaha.
Yeah, thanks for that introduction, Eduardo. And I mean, for a few disclaimers, like we come at it like from our own experience, and like like not we it's a very high level and kind of end user oriented kind of tech stack that I try to present. Like it's like, of course, simplifies a whole bunch of like potential like details like on each of the aspects of uh, either like from early sales all the way down to like actually delivering the building. Like there's there'll be several sub ecosystems, I guess, like of uh, software tool chains, etc., like, and how it interacts with the real world, like production systems, etc. Like, so from what we try to present is like what is of value and interest to the end buyer, should be of interest to the architect, and should be of interest, of course, of interest to the developers or the investors, right? That and so how can technology help address their principal concerns of each of these three main characters, let's say, in the early part of a project. And so we thought, like, what is of interest, and like video game technology is like super useful in that sense. We have found that it like it exposes people, like the end buyer, to trade-offs, right? Because typically, like, that is very difficult as architects to present to a client, like whether the end buyer would typically not even present at the table initially, early on, and to the developer, like, what are the trade-offs? Because like, that's why they are very sticking to like whatever is tried and tested. They say like maximize floor area. It's not necessary, because if you present that there are other trade-offs that could be made, and like that trade-off is actually validated by the end buyer who's going to pay for the product in the end, like so that that bringing those two parties to the table at simultaneously and presenting the trade-offs, we found is very, very rewarding, both from the end buyer perspective and the developer's perspective. Because on the one hand, like, the developer is happy that, like, they're going to build the thing that, like, the end buyer is willing to pay money for, right? Like, they don't have to take a risk after the fact, like, and the end buyer is also happy because, like, somebody is taking time to explain all the trade-offs, like, of potentially one of their biggest purchases in their life, right? Like, a house is maybe one of the biggest financial commitments anybody makes, like, in their lifetime. And so so this gamification brings those aspects of trade-off, we found, like it foregrounds trade-offs, and you can use that framework, like, to then start including other principles. You said wind data, like you could, like, have carbon emissions, you can have you can have, like, other, like, social impact factors, how much employment you generate. All of these could be presented in a trade-off matrix, and people could then choose for themselves in a way, like, or at least discuss together. And so that's, we are genuinely excited. We are only scratching the tip of the surface, we understand that, but we're very excited to see where all of this goes. And all the architectural technology is, like, maturing enough that, like, they can afford, like, a web facing front end,
like even if the heavy lifting is done like on servers on the back end, like weather data is all crunched, but like it is presented in a in a format compatible with the end user, which is both web friendly but also friendly with like this kind of gamified format, I suppose, one way or the other. Yeah.
Great, thanks, Sergey. So I don't know, Wissam, would you like to add as well before we go back to Abel for final comments?
Yeah, I mean, I just had a couple questions. Sorry, I joined in a little later, but I mean, my personal research is somewhere between Sergey's presentation and Greg's, and it's quite amazing to see both presentations today. But I guess I have a couple questions. One is for Greg, is and is it oh yeah, so with regards to making sort of these objects smart and sort of capturing these data and relaying this information between the digital form of it and the physical form, and I guess I have been looking at that for some time now. The idea has been sort of bouncing in my head for a couple of years, and the one thing is this idea of sensory and capturing data on the physical object itself, and how can we, like, what is your biggest constraints when it comes to making the physical object smarter over time as technology evolves? Is it simply updating the technology of it, or is it like, is this object sort of always going to be within that constraint of the technology in the period in which it was built? Or is there a way sort of we update the technology as we update the digital one? As we know, the digital one is probably much easier to update when it comes to keeping up with software and technology, etc. Hopefully, I hope my question is not too confusing, but yeah.
No, it's a good question. Actually, I saw a recent example that it's related, and it was about applying computer vision, machine learning to old drawings, basically. So this was from like a process power plant scenario. These old documents are called PNIDs. They're just basically descriptions of like a system, and they're all 2D, old-fashioned, non-digital, right? And so with computer vision and some training, it became intelligent. And I saw the same thing applied to like sensors on a pump, where even if that thing may not be intrinsically intelligent, with computer vision, you can start to like actually pull all sorts of information from the environment. It's amazing. If you think about what a Tesla car is doing when it's driving down the street, it's like understanding the world, and that world is just pixels. I think there was another presentation, I think yesterday, that was showing kind of a classification of pixels based on computer vision. So I think that's huge. There's a huge amount of research in that space. And I think that's what's driving all the, like a lot of it, like the smart cars, smart infrastructure. And obviously, if you start adding new components, then those are going to be probably wired into like a network and start feeding IoT data into it. So that's a short answer, but I think computer vision is a big piece of that puzzle.
Great.
So you had a second question with them, or should
Yes,
we move
yeah, I do have one more question
Yeah.
for Shijay. Yes. Also, the other part of sort of my personal research is the idea of the components and kits of parts, and that Shijay has touched upon towards the end of the presentation. And I guess my biggest question is, what is the constraints when it comes to constructing buildings when it comes to kit of parts? Is it simply the scale? And also, I guess the sub question is, what determines these parts? Is it simply architectural elements? Or do we build things within a reasonable spatial scale, or do we build them within elements? So I guess those are the final question I had.
Yeah, it's a great question. And I mean, again, I have to say, like, we are discovering these things through a live project, like, and that's one of the ways, or the only ways, that we know how to do this, like, because we are trained as architects, and like we collaborate for everything else. And so from our experience on the current project, and also the student-led work, like preceding that, there's always a tension between building elements and spatial modules. And also computationally, like how do you distinguish what belongs to a module, right? Like,
Right.
and because if you start like clearly nesting one set of elements into a like a kind of hierarchical tree, like then like, you know, there's difficulty on the design side and the spatial side, because some elements like kind of permeate between two modules, let's say, for example. Like, so there are these kind of what kind of data structure and like how do you capture these things computationally or even as BIM models, or is a bit of an issue that we are discovering. And the building elements, like, they come as a consequence of two pressures. On the one hand, like these spatial pressures, like how what is the granularity that allows for like enough variety as far as the user is concerned, because they don't care if they have 3 different types of columns, they care if they're like 3 different types of bedrooms. And but on the other hand, like a manufacturer definitely cares if there are like 3 different types of columns or 3 different types of floor slabs. And because building trades are distributed in this way, so there are these kind of, let's say, pressures to manage, like when it comes to which elements to design for and how to granulate it. So yeah, like I believe like the right approach would be to have a hierarchical model structure with like information that gets added or deleted or suppressed based on who's viewing it. But then there's always an issue of mapping one person's elements to other people's other professions elements and so on. Like, yeah, so we are building the car as we are driving it. So I will report back when when we know more.
No, it's great. It's really interesting, and I appreciate you about letting me into the discussion. I know I presented yesterday, but it's really good. Thanks a lot.
Great. So look, everyone, thank you very much for joining the panel. I think to be respectful of time as well, and considering the last session we have today, we would just like to ask for a final quick remark from everyone around the table. So we have about 2 minutes between all of us, so please be quick and brief. And Brendan, I'll let you start.
Thank you. I think there are exciting times ahead. I think there is not one overall unifying direction that we all are marching in. I think we've got sort of a very even individual walk forwards. I apologize, I'm not explaining myself, but I think it's very diverse. I think it's very democratic, and that's only a good thing. Thank you.
Very good. Thank you. Thank you, Brendan. Paul, would you like to go next?
First, thank you. I enjoyed everything. I mean, it was a very interesting talks from everybody. I'm a bit lower in development career, and I really enjoyed every discussion. I agree with Brendan about basically the democratic process in the development of all the projects and all in architecture. And yeah, thank you very much.
Very good. Thanks, Paul. Shajay, would you like to go next?
Yeah, I'm like genuinely optimistic of let's say techno-optimistic, that like computational technologies are maturing enough to now actually provide solutions to really pressing issues of the 21st century, like whether it's social or ecological sustainability, and also new opportunities, like really capitalizing on new design possibilities, but also new job profiles, and yeah, as Brendan said, really exciting times, yeah, like really a participatory future that generally excited by. Yeah.
Great, thanks, Shajay. Wissam, do you have any final comments?
Yeah, I was just going to say it's super amazing just to see the wide range of research that's been that I've seen in the past 3 days in the conference, and it just sort of not only gives me the hope that our tools will improve with time, but it also sort of puts ideas in our heads. and it sort of improves upon our research. So I agree with everyone. It's definitely an exciting time, and I'm happy that I was able to see this wide range of research from everyone. So it's great.
Great, thank you. Greg?
Yeah, thanks. Great sessions. I really enjoyed learning from everybody. Even I minted my first NFT in one of the sessions. So it's like, instead of just hearing about it, I like just doing it. So I really appreciate that. And I think that's what's cool. Like, I'm really interested in like tangible prototypes. I saw a lot of examples of like functional working code. And I think that's the key. Just empower people, inspire people to go like make things, like even that compression bridge example, super cool. Or the video showing the skeletons being captured. I like showing real things. I think this is a group of people that go beyond just a research paper. And I love seeing actual demonstrations of results. So super exciting. And I would hope to have the opportunity to work with any and all of you to, help build functional prototypes at some point. My accent is American, but I now live in London. So we can hopefully meet up at UCL at some point, maybe, and
Sure.
do some cool workshops together. So thank you.
Great. Yeah.
Great, thank you very much, Greg. And just to conclude, well, thank you very much, Abel. I fully agree with Greg and with everything else that was said. I think it has been a brilliant 3 days, super informative, and definitely a lot of takeovers for us from the software development side, and many ideas for us to invest on. And looking forward to next year. For sure, we will be very, very keen on working, and hopefully we'll have a live session we can all meet. But yes, thank you very much, Abel.
It's a pleasure. I'm very glad to have you all here. I thought it was super interesting to see what the industry is actually doing with the technology and the insights being created in academia, and vice versa as well. Academia benefiting from technologies being created in the industry. I think from the presentations yesterday and today, we can really see that our models of a value are changing, our models of teaching and education, they are changing, and our models of production as well, they are changing. What the so-called fourth industrial revolution is very much a cognitive revolution, and it spans in it's so cross-sectional that is quite amazing. And it is, there's emergent collaboration from all different sectors and different types of people contributing to this transformation, to this digital transformation, is really key. So it's a real pleasure to have you all here. I will now conclude the session, Eduardo, if you agree. Yeah, and I will play closing remarks by Professor Hanna, who helped to create this conference. I think Sean is actually lecturing right now at UCL. So it's a very different notions of time and space. Sajay was, I believe, just getting back home when he was at the same time presenting. So that's really cool. So I will just invite you all to watch this keynote, and I'll just have some final closing remarks, just like some housekeeping notes.